Hello, this is Surya from team name not found, and we've chosen the problem statement Smart Irrigation System for Precision Farming. And it's a hardware based project. So let me just get down to the actual details. So as you can see, the solution we propose is on your right, on my right side. So you can see the rover here. So the rovers practically a prototype. Actually, it was for the internal hackathon. This is not the finalized model. This is just a prototype of the prototype. Okay, so basically it's a all-terrain rover. I didn't want to focus it onto particular fields. So it was an all-terrain based rover. So and so the problem statement practically addressed conditions to assess like the water levels, assess the temperature, I mean the weather, and give real-time alerts. So this is what I have proposed. So as far as the concern with the rover, with we've used, I mean we're going to use something called as computer vision paired with GPS together, putting it into a putting it as slam. So SLAM would help us map the area and give us a visual representation of the area, I mean, of the practical land on which a rover would be running. This land in which we detect for soil moisture, temperature, humidity, and stuff, and weather conditions too. So all these data would be processed because these are all raw data. We process this and we put it into a dashboard. So the sample dashboard looks somewhat like this, as you can see. I'll elate it with your picture later. So moving on from the dashboard part, we'll come to the machine learning model, where the machine learning model would be the second half of the project, where we'd use particular models like random forest to predict how much water should we give for the plants, and RNN models to basically time the irrigation. So I'm running up with the idea. And as far as the concern with the communication from the sensors to the actual data, I'm using the LoRaWAN. So why specifically LoRaWAN? Because it's very good in places where there's no network connectivity to. So to give you a visualized understanding of what I'm doing and all the stuff, we'll go to this slide, where I have this picture. So as you can see, I have my agricultural field where I'd run my rover. The rovers would be equipped with these sensors and weather API as of now. So uh, they would be communicated using the LoRa model for the dashboard. The dashboard would contain all the information regarding the like the real-time I mean information. The computer vision and the SLAM part where I mentioned you, that would give me a heat map based on the dashboard, telling me this. I mean this part of land has got moisture content and this part isn't. So all this would be put into an application where a farmer or any technical person, anybody who's like monitoring the field would easily get updates. It's all real time updates. I've chosen Flutter for basically it's a single code base for multiple platforms, so that is why. And here I've given a breakdown of what components and stuff I'm going to use. So as for the rover, I'm going to use a 3D printed frame for the chassis because I wanted it to be perfect for my kind of rover. And I'm using a GPS and a camera for the CV model for the SLAM, and I'm using a Raspberry Pi for the mini computer and the coordination part, and I'm using a solar panel. I want it to be a renewable kind of project because I don't want to use a lithium ion battery, which would again produce waste, and it would be another problem. So I'd use a solar panel which is very good enough to stay, I mean power my rover. As far as the more sensors, I've already mentioned the soil temperature, humidity, pH, electrical conductivity. I'm also thinking of adding light sensors and chlorophyll sensors, and also the photosynthetic radiation sensors to govern the plant, I mean to monitor the plants too. As for the communication part, I've mentioned LoRa, and the software technologies is basically C and C++ for the embedded programming part for the communication of the sensors to the data. The data pre-processing would take place using Python and NumPy, pandas and scikit-learn stuff. As far as the plotting part, I'd use GIS and OpenCV basically, and for the app I mentioned you Flutter. Coming to the feasibility and viability, why should you buy my product? Or talking about the business perspective, so my product, as if what I've proposed, it's a very sturdy product. For first of all, my keyword first mentioned, it's very sturdy, and it's all packed in one small box as a thing. It's imagine it as a remote control card a kid would want to play. So it's all packed in one. It's a one stop button for all the things. And the complete assembling of the project is all I mean, a person with basic technical knowledge could assemble it, so it's not a very difficult project to even upscale it. And renewable energy is one of my key points I love to put forth, because I'd really wanted to address it with a solar panel rather than going for rechargeable batteries like lithium ion batteries or stuff. And currently there's high demand in agriculture, and going with an autonomous solution with agriculture would be a literally 1,000% hit into the market. So as for the risks, I've predicted a few risks, one being sensor precision. So sensor precision is one most important thing, because we are dealing with the raw data, and sensors directly hitting the physical conditions. So that would be a problem. A bad problem with that would be real time analysis, because we're using real time data. So this would be paired with resistance to change from farmers, because we're using so many technical things. A farmer would not be ready to accept the change quickly. So these would be my basic problems. So I've come up with solutions, one being the sensor precision and the quality of data for real time. For the sensor precision, we could do a quick analysis, basically a quick testing now and then to understand the precision. So as far as the bottlenecks with the latency, I've planned to insert multiple sensors around the same area. So the sensor data would give me an average rather than picking out only one. So these are all like very in-depth concepts with the presentation. So I'd really love to talk about the impact and benefits, but let me just put it in short. The impact would be basically a farmer who's really tirelessly predicting, or like I mean, guessing when to water his plants, would have a short solution, a one shot solution to just hit on it, and then you have your irrigation done. So he can be very confident with what's happening. The problem I really think of is investment. Putting an investment into a rover and believing it, it's in the hands of the demo, and it's in the hands of the technician who's really got to put it forth. It's all marketing there. So the solution, it's got tons of benefits, as if starting with technology being a friend, hand in hand friend, who can boost both productivity and sales. It's a real boon for everyone. Economic advantages would be again coming up with, increase in sales, loss, there would be much lesser loss. And environmentally, we'd be, using renewable source of energy is one thing. We'd be reducing the carbon footprint, we'd be minimizing wastage, we'd be minimizing the waste of water, which is one of the most important concern. So as far as my research part, I've put tons of resources here. This was not all. I've used a lot of AI chatbots and stuff for my reference too. So it's a pretty well planned project. I hope you loved my presentation. So as far as the internal hackathon, we were only able to achieve this much. So it is a basic dashboard with a basic rover that just moves like a remote control car. Thank you all. So I hope it's a wonderful hacking experience. Thank you.